Right, so we have been talking about heat capacity and specific heat capacity. So remember, when we talk about heat capacity and specific capacity, it simply talks about the energy that is needed to raise the temperature of a substance by 1 degree Celsius, so 1 Kelvin. But specific, you are raising the temperature of just the 1 kg. So that's the key concept. So these guys have to do with raising the temperature of a substance by 1 degree Celsius. If you become specific, you mean a 1 kg. What is the energy that you need to raise the temperature of a 1 kg? So that's the idea. And of course, if you still remember, there are some calculations that I did talk about in my previous video. Heat capacity is equal to the energy divided by the change in temperature. And specific heat capacity is simply the energy over the mass and the change in temperature. And if you want just to find the energy from this one, need absorbed or released, the energy is equal to mass, specific heat capacity, and change in what? Temperature. But I want to talk about something before I look at those ones. Sometimes you are going to be carrying out experiments to find the specific heat capacity of a substance, such as maybe a metal, a liquid, and so on and so forth. So what you're going to do is that sometimes they may give you an emission heater. So you may use what we call as being an emission heater. So they can use a heater, and remember, an emission heater converts what we are calling as being electrical energy. It converts it into heat energy. You can think of maybe the heating element that you use to maybe heat up your water when it is actually cold. So it converts electrical energy into heat energy. So you can actually find how much energy a heater actually supplies. So you can actually find how much energy does a heater in this case supply. Remember, from your calculations that you did, you need to remember that energy can also be given in this case by power multiplied by time. So if you know for how long the power, for how long the power has been supplied, you can calculate, electrical energy in this case. So this formula is very important because we can actually combine it here. Where there's E, I can replace with PT from here. So that is what you need to. That is what you need to remember. For example, there, if I want to find the specific heat capacity and I was using a heater, where there's energy, I can replace power multiplied by time. So that P is representing power and that T is representing time over the mass and the change in temperature. So it is possible you can do that. But specifically when you are dealing with experiments, you also need to remember that apart from you using this one, energy power is equal to voltage times time. So you may know the voltage, the current, and the time. You can still calculate your energy. So I thought of bringing this to your attention because I know some of you have not yet looked at a topic we call electricity, where we are going to look at this one in more detail. But if you haven't, you can please watch my videos and you'll be able at least to learn something from there. All right, so you're able to combine this with that and apply them. All right, so now let's look at the solution to the question that we have there. It says how much heat energy is needed to increase the temperature of a 0.2 kg mass of gold by 10 degrees Celsius. And they tell you that the specific heat capacity of gold is simply 300. That is what they have given us. So what do we need to do in this case? Well, it is very simple. Let's look at the solution to this question number 1. So what is the information that we have been given there? So the data, the mass, they have given us, it is a 0.2 kg. Then if you look at the change in temperature, they say the mass of gold by 10 degrees. So the change in temperature is 10 degrees Celsius. And the specific heat capacity is 300 joule per kg degrees Celsius. The question says how much energy. So they want us to find how much energy. That's what the question says. So remember, energy is equal to mass, in this case the specific heat capacity, and the change in temperature. So therefore energy will be equal to the mass, which is a 0.2 kg multiplied by the specific heat capacity 300 joule per kg degrees Celsius times the change in temperature, which is 10 degrees Celsius. So if you notice there, the kg and the kg will cancel the degrees, and the degrees will cancel, remain with just the joules. So we can just multiply that. When we multiply 0.2 multiplied by 300 multiplied by 10, what is that going to give us? It is going to give us 600 joules. So that is the how much heat energy was needed to increase the temperature of a 0.2 kg mass of gold by 10 degrees. So this is the energy that was needed. I hope I'm trying to make sense to you, and it's making sense to yourself. If you don't understand, please, you can go through as many times as possible. Practice is very important. Let's look at question number 2. Question number 2 there says that a 0.5 kg metal block is heated by a 50 watt electric heater. So that's what they tell us. So according to the data, electric heater for 90 seconds, the temperature of the block rises from 20 degrees to 45 degrees Celsius. Calculate the specific heat capacity of the metal. So that's what they're telling us. So according to the data, if you look at it, the mass is simply a 0.5. They have given us power, which is equal to 50 watts. That's the SI unit. And the time, they have told us it is actually 90 seconds. And they have told us the change in temperature. So remember delta theta. Remember, when we talk about the change in temperature, it could be the final temperature T2 minus the initial temperature. So therefore, the final temperature is 45 minus the initial temperature, which is 20. So when you subtract there, it will give you 25 degrees Celsius. That is the change, in temperature. In other words, that was the rise in temperature, or the temperature change that we are having there. So that is in K, in kg we are having. All right. And the question says we find the specific heat capacity of the metal. Remember what I said, specific heat capacity is equal to, in this case, the energy divided by the mass and the change in temperature. But if I look at the energy, remember that, like I said, energy can also be given by power times what? Time. That can give you how much energy is there. So when I combine this, it will give me how much energy was supplied to this metal block. So therefore, in this case, it is going to be the energy will be power times time divided by the mass and the change in temperature. So specific heat capacity of this metal, the power is simply 50 for how long? 90 seconds. Remember, that is the SI unit in this case, which is very much okay, divided in this case by the mass, which is a 0.5 kg correct unit, and the change in temperature, which is simply 25. Therefore, if you were to punch all these on your calculator, that is 50 multiplied by 90, we are getting, in this case, 4,500 divided by, if you look at 0.5 times 25, that is giving me a 12.5. So if you divide that 4,500 divided by 12.5, it is simply giving me a 360, and that on top, remember, energy joule, that one was in kg and that one was in degrees Celsius. So it is 360 joule per kg degrees Celsius. That is the specific heat capacity of the metal. Please watch out for more of some further questions. I'll look at now further questions where I combine specific heat capacity and latent heat of fusion. So we'll look at all that. Watch out for more so that you are able to benefit. If you love what I do, please, you can subscribe and you can press that like button, so that we can continue to produce more of such videos so that others too can actually benefit. Thank you so much for watching.